Hello guys, and welcome to this full course about MySQL in 3 hours. In this video, you will find everything that you need in order to learn and work with MySQL. And if you want to learn that step by step, all the chapters are available in the description. So first, we are going to see how to install MySQL. So first we have to look for MySQL on Google. You click on MySQL official website. Then we click on downloads. Then you look for the MySQL community downloads. So as you can see here, we have a lot of MySQL community downloads. And in our case, we are going to install that for Windows. And you choose to download the first one, which will take the least amount of storage. So you click on download. And as you can see here, we can log in or sign up for an Oracle web account. So we click on no thanks, just start my download. Once the download is complete, so we click on MySQL installer. Okay, so first, as you can see here, we have to choose a setup type and we have select one among these 5. So we have developer default, server only, client only, full, and custom. So we stay with the recommended, which is the developer. We click on next. As you can see here, you may get different things displayed on your screen depending on your computer and the requirements. So in my case, I would just click on next. Yes. And here you can see the list of the products that will be downloaded. So you click on execute. So this may take some time depending on your internet connection. So I will pause the video. Okay, so once all the products are downloaded, you click on next, execute. This also may take a couple of minutes, so I will also pause the video. Once all the products are installed, you click on next. Product configuration will now work through a configuration wizard for each of the following products. Click next. So here we have type and networking. We have the connectivity, TCP IP, we have the port, so we leave everything as it is, we don't change anything. We click on next. So here we have the authentication method. Use strong password encryption for authentication, recommended. Click on next. And here you create your MySQL root password. So here we have created our password. We click on next. Windows service. So run Windows service as standard system account. Next. Execute. So the configuration of MySQL was successful. Click finish to continue. Finish. Next. Finish. Next. And here you put your password. Check. Connection succeeded. Next. Execute. Finish. Next. Finish. So now we have the following workbench that says welcome to MySQL workbench, and here you have your connection. So generally we have the local instance MySQL IT, but if you don't have this one, you can create new connection, set up new connection. So you give it a name, local connection. So here on the password you click store in Vault, you put your password, OK, and press OK. So here you have your local connection, you click on that. And here we have MySQL workbench, which is ready to be used. Nowadays, SQL is one of the most in-demand skills in order to become a data analyst or data scientist. Thus, learning and understanding SQL will help you a lot to get a job as data scientist or data analyst and to work in a better way in data science and data analysis projects. So in this course, we are going to see first what is SQL, what is an RDBMS, what is database and what is a relational database. We're going to mention some famous RDBMS used in the real world. We'll explain tables, ER diagram, keys, constraints, SQL indexes, MySQL data types, SQL command types, and finally, we're going to have some hands-on all the defined concepts above using MySQL. So first, what is SQL? SQL stands for Structured Query Language. It is designed for managing data held in a Relational Database Management System, the RDBMS. So RDBMS stands for Relational Database Management System, and it is a type of software that allows you to manage data in a relational database, mostly using SQL. So database is a collection of data stored in a computer system, whereas a relational database is a type of database where data is structured and stored in tables, where generally tables are related to each other by keys in order to form an ER diagram. So famous relational database management systems used in the real world, we can mention MySQL, the one that we will use in this tutorial. We have Microsoft SQL Server, we have PostgreSQL, Oracle Database, etc. So what are tables? Tables are database objects where data is structured and organized in a row and column format. As you can see here, the horizontal line in blue represents a row, or it is also called a record. And columns are called fields or the vertical lines. So we have ID, first name, last name, and phone number. These are called columns or also fields. We have two types of keys. We have the primary key, which is a special column in a table used to define each record in a table. It is unique for each table, so each table will have only one primary key. And we have the foreign key. It is a field or many fields, so a table can have one foreign key or many foreign keys in a table that are used to link tables. So a foreign key in one table represents a primary key in another table. ER diagram stands for Entity Relationship Diagram, and it is a graphical representation to show the relationships between tables. Here we have an example of an ER diagram. As you can see, we have three different tables. We have grades, students, and courses. Each table has only one primary key. For the grades, we have grade ID. For the students, we have student ID. And for the courses, we have course ID. But also, the grades table has two foreign keys. We have student ID and course ID, which are primary keys in the two other tables. For the foreign key in grades, which is student ID, it is a primary key in students table. For the course ID, it is a foreign key in the grades table, and it is also a primary key in the courses table. So as we have mentioned, a foreign key in one table is a primary key in another table. Constraints. Constraints are rules that are applied on columns. Primary key and foreign key are types of constraints. When we say that this column represents a primary key, it is type of a constraint. We have not null constraints, which means that the column cannot have a null value. Unique, all values are different, which means that no duplicates. Check, so it is used to check a given condition. And we have default, which is used to set a default value if no value is assigned. For example, if the value is null, with the default constraint, you can give it a default value. Then we have the indexes. Indexes are used to speed up data querying. The query is applied only on the selected columns to retrieve data. For example, if we have a big database and we have big table, which has a lot of fields, a lot of columns, so you can create an index and select some columns that are mostly used by the data analyst. So by using indexes, you will only retrieve data from the selected columns, and you will gain time because you are not going to analyze all the data set or all the table. We have three commands when working with indexes. We have create index, which is used to create an index, create unit index, which means that creating indexes with no duplicates, and we have drop index, which is used to remove an index. MySQL data types. So with SQL, we work mainly with three data types. We have numeric, string, data, and time. And for more details, we are going to the official documentation of MySQL in order to understand better the data types. The link is available in the description if you want to follow with this video. Okay, so now as you can see here, when you click on the link provided in the description, we have chapter 11 data types. In the table of contents, we have numeric data types, data and time data types, string data types, and some other data types. But most of the time, in practice, the three first types are the most used. So we have numeric, date, and string. So if we click on numeric data types, we can see that MySQL supports all standard SQL numeric data types. They include the exact numeric data types, so the integers, as well as the approximate numeric data types, which are float, real, and double precision. So if you want to understand in depth all the different data types, you can click on one of them, for example on double precision, and it will give details about each data type. So the second data type is the date and time data types. So as you can see here, the date and time data types for representing temporal values are date, time, timestamp, and year. For example, if we click on date, so the date type is used for values with a date part but no time part. Okay, so only for dates, and it is in the format of year, month, and day. And here we have the range. So the same thing, if you want to understand in depth all the different data types, you can only click on one of them and you will have all the information. The third one is the string data types, and here we have 8 types. We have the character, so the varchar, binary, var binary, blob, text, enum, and set. For example, if we click on the char, so the char and the varchar types are similar but differ in the way they are stored and retrieved. For example, the char can hold up to 30 characters, and for example, for values in varchar columns are variable length strings, and the length can be specified as a value from 0 to 65,535. Same thing for the other data types. If you want to understand in depth, all the information are available in this chapter. Now we'll talk about the SQL command types. As you can see here, we have 5 different types. We have DQL, DML, DDL, DCL, and TCL. The DQL stands for Data Query Language and used to select data from database. It has only one command, which is the select command. The DML stands for Data Manipulation Language and used to modify and update the database. It has 3 commands. We have the delete, the insert, and the update. The DDL stands for Data Definition Language and used to create, define, and modify the database schema. The commands we have the alter, create, drop, and truncate. The DCL stands for Data Control Language and used to control access to data stored in database. For the commands we have the grant and the revoke. Finally, we have the TCL, which stands for Transaction Control Language and used to group a set of statements into a single logical execution unit. We have 3 different commands: the commit, rollback, and save point. Okay, so when we open MySQL Workbench, we get the following window. If you haven't already installed MySQL Workbench on your computer, you can find the link in the description to download it and to create new connection. So we click on local connection, and we get the following window. So as you can see here, we have the navigator where we find the schemas, which are the databases. We have the window where we create our queries, and you can create new ones. So create new SQL tab for executing queries. Here we have SQL additions. Here we have the output, so the action output with the time, the action, and the message, where of course we have the duration. And here above we can choose whether we want to display the schemas or not, display the action output or not, or the SQL additions. So we are going to work with the schemas and the query tab. As you can see here, we have the system database, which is always present, which is default database. We have 2 more databases provided by MySQL Workbench, and the DB test, which is a database that I have created. Okay, so to create a database, we have 2 methods. We can cap in here and create new schema in the connected server. So give it the name DB1, and we leave everything as it is. We click on apply, okay, apply, finish, and we see the database. It is displayed in here. To see the tables, so we have tables, views, stored procedures, and functions. The same thing for the provided, so we have the word, we have tables. In each table we have the columns, the indexes, foreign keys, and the triggers. So we are going to create a new database from scratch with tables and columns. Okay, so come back into query, and here we have the execute command, so execute the statement under the keyboard cursor. Here we have the limit number of rows, so you have limit 10,000 and you can display up to 50k rows. Okay, and for example, if you want to create a database, we write create database, we call it db2, for example. Okay, we execute the query and we refresh the schemas, so we see our db2 is created in here. For example, if we want to use one of the provided databases, we can write use, for example, Sakila, and we execute the statement. We get the table, so we are inside this database. For example, we can select all the rows in the actor table, for example. To do that, we write select all. Okay, so the asterisk means all from actor. Okay, execute, and here we do have the output. Okay, so actor ID, first name, last name, and we have the last update. Okay, now as you can see here, I have written all SQL keywords in the uppercase and the titles, the remaining data in the lowercase, and all the queries need to end with a semicolon. Okay, so the syntax is like this. It is better to write your queries like this. To add a comment, we use double dash, so dash dash. This is a comment. Okay, and if you execute that, nothing will be applied. Okay, so this is a comment. And for example, if we want to use strings, okay, so we execute that, and for example, we add condition where, okay, first name, for example, first name equals to, you can use either double quotes or single quotes. Okay, for example, if we use single quotes, we will get the following. Okay, and if we use the double, it is the same thing. Okay, but it is recommended to use the single quotes. Okay, so if we use single quotes, it will be better. Okay, so we execute that, and each, for example, each word, it will be in a separate line. For example, you write select in one line, then you write from your table, then you write your condition. Okay, it is better than putting everything in the single line. Okay, it is possible, but it will be clearer if we put each word in a separate line. Okay, because as you can see here, even though if we write all the words in separate lines, the query will be executed at the end of the semicolon. It will not execute only select all. Okay, so the query is all this. Okay, so this is an example of a query where we select all the rows from the actor table where the first name equals to ed. Okay, so this is a query. Now, if we want to create another database, for example, that we will call create database. Okay, we call it, for example, students info, right? We execute that, and if we refresh, we get our students info database. We are going to use that, so we write use students info, right? We execute, so we are inside our database. Now we will create tables. For example, we create the first table, we call it create table, we call it students. Okay, so in order to create table, you need to put at least one column. Okay, so we start by the ID, so student ID, it will be an integer and it will be not null. So we have the column name, we have the data type, and we have the constraint. Okay, the second, it will be each student has first name, Same thing, it will be varchar with 20 characters or 30 characters as you like. We can also add constraint, it will be not null. Okay, same thing, we write last name, it will be varchar 30, and for example we add date of birth. Okay, date of birth, it will be a date. Okay, so we can define our table like that. And as we have said, each table needs to have a primary key. So to create our primary key, we write primary key. Okay, and we select student ID. Okay, so if we create our table, we execute the statement, and if we refresh, we get our first table, which is students, and it has all the columns. So student ID, first name, last name, and date of birth. It doesn't have any foreign keys. Okay, and we have any indexes. We haven't created any indexes. So we create another table. We call it courses. Okay, and in this courses we will have course ID, which will be an integer, and also it is not null, and we have also the course name, which is varchar, for example. Okay, which can be up to 30 characters. Okay, and we create our, we also add the primary key. So it will be the course ID. Okay, and we create our table. So we have another table. If we refresh that, we have two tables. So we have the courses and we have students. And now we create a third table. So we call it create table. Okay, I call it grades. Grades, and it will have also grade ID. Okay, so the grade ID, it will be int and not null. Okay, we'll also have the student ID. Okay, and it will be int also. We'll have the course ID, it will be an integer. Okay, and we have the grade, which can be a float. All right, so here we created our table. As you can see here, I didn't define the primary key inside the table as I did. Okay, what I will do is that I will add the primary key using another method, which is alter table. We have grades, and we select add primary key, which is grade ID. We select the statement. Okay, so here we have added grade ID as the primary key in the grades table. Okay, now if we want to drop a table, for example, drop table, we write drop table grades. Okay, so before I execute that, when I refresh, we have the grades table, and when I drop the table, execute, we don't have the table anymore. Okay, so as we have said, each table has a primary key, so we have two methods to add the primary key, whether when you create the table or you can add it. And also, as we have said, each table can have one or more foreign keys. So in the grades table, we can add two foreign keys. So we have student ID and the course ID. So each grade, it will be for a student for a given course. Okay, so the course has a title as it has an ID, and each student has first name, last name, has an ID and date of birth. Okay, so we can add the foreign key using this method. Okay, so we write foreign key. Okay, foreign key, which is student ID. Okay, all right, references, it is in the students table and it is the student ID. Okay, so we select student ID as foreign key in the students table. So if we execute that one more time and we refresh our table, we get the grades table is in the students info database. We can also add the course ID or foreign key using another method, which is alter table. Okay, we have the table grades, so add foreign key, which is course ID. Okay, and it will be so references from the courses table, and the column is the course ID. Okay, so here we have our statement alter right. So we will see the primary key, the foreign key, and the link, the relationships between the three tables when we create our ER diagram. Okay, so to create an ER diagram, we go to database, reverse engineer, okay, local connection, stored connection, local connection. We click on next, next. So we select the student info, right? Next, next, execute. So here it has created an ER diagram for us, as you can see here. So we have the grades table, students table, and the courses. As you can see here, the grade ID is the primary key for the grades. The students ID is the primary key for the students, and the course ID is the primary key for the courses. Okay, for the student ID and the course ID in the grades table, it is represented as foreign keys. They are foreign keys in the grades table. As you can see, when we click on it, we have the relationship between the three tables. So this is how we create an ER diagram. So we are going to continue with some DDL commands, which stands for Data Definition Language, and we are going to insert, delete, and update some rows in our tables. But before we proceed with that, we have first to delete some of our databases. Okay, so we write drop database db1. Okay, we don't need this in this tutorial. Okay, and we do the same thing for the db2. We can also delete the db test. Okay, so like that, we have only what we need. Okay, so we have the students info with the three tables. What we are going to do is that we are going to insert data into our students table, okay, which has 4 columns. We have the student ID, first name, last name, and date of birth, and we are going to do that in 3 different ways. So we can add single rows without column names, okay, as we are going to do. So we write insert into, and we write the table name, so students. We select our values. So here we didn't add the column names. We write values, and all the values that we are going to write between the parentheses have to be in the same order which is defined for the columns. So we have student ID, first name, last name, and date of birth. For student ID, we write 1. First name, we write, for example, Jack. And for the last name, we can write Lee, for example. Okay. The fourth field is the date, and as we have said, for the date it has the year. Okay, then we have the month, and then we have the day. Okay, so we have written our example in here, and the query needs to end with a semicolon. Okay, so we execute that. As we have said, in order to select or to view the data inside the table, we write select asterisk, which means all, new line, from, and we write the table, which is students. Okay, we execute that and we see our output. So we have added the student name, student ID, which is 1, first name, which is Jack, last name, which is Lee, and date of birth, which is an example. Okay, so we can add also values or rows into our table using the names of the columns. So we write insert into our table, which is students, and we can add the names of the column. So we have student ID, first name, okay, last name, and we do have the date of birth. Okay, new line, and we add values. Okay, values, for example, we add the ID, it is 2, the first name, for example, it is John, right? The last name we can add, for example, LA, and date of birth, for example, we can add date. Okay, so if you execute that and we select, okay, so we have an error which can be student ID without the S. And if we execute that one more time, so insert into our table the given values and select all from students, so we have our new row. Okay, now we can add multiple values using the same thing. So multiple values using the column names in our table or without the column names. So to do that, we can write insert into, so we can add students. So for the values, I have directly some rows that I have written before. So I add directly these rows, okay, to save time. And if we execute that, so same thing, we select all from students, and here we have our table. So we have student IDs, we have the first name, the last name, and the date of birth. Okay, as you can see here, it is recommended to use the dash for the date since it is used in the syntax, in the defined syntax of MySQL, but if we write directly the slash, it will be converted to a dash. Okay, so it is preferred to write your dates in this format. Now, if we want to delete a row from our table, we can use the following syntax. So we have delete from, we write our table, students, and we select where, so this is the condition, where student ID, for example, student ID equals to 1. Okay, and if we execute that, so if we copy paste this one, and if we execute that, we have the first row, it is deleted. Okay, so we write delete from students where student ID is equal to 1. Now if you get an error or this statement or this query cannot be executed, you can go to edit and go to preferences, you go to SQL editor, and you remove the check from the save updates. Okay, rejects updates and deletes with no restrictions. Okay, so if it is checked, you can uncheck that and it will be okay for you to apply the updates and delete rows from your tables, and you click OK, of course, right? We can also delete another row, for example, delete from, so we write students, and where, for example, date of birth equals to, okay, and if we execute that, select all from students. Okay, so like that we use the delete statement from students and you write here your condition. So as you can conclude here, select is used to query or to retrieve data from a table. So using this syntax, select, this is where you write your columns, and from your table. The same thing for the where. So where is used to put a condition in order to execute a given statement. For example, you write delete. So we want to delete a row from the students table where the date of birth is equal to this date. Okay, so now if you want, for example, to update a row or a given value in some columns, so we write the following. We write update. You write the name of the table, so students, and you set, for example, we change the last name of, for example, we change LA to, for example, another value. So write last name equals to, for example, tick. Okay, where, so we add the condition, student ID equals to 2, right? Student ID equals 2, semicolon. And if we execute that, okay, so we select all from the students, and we see the last name has changed where the student ID equals to 2. We can do the same thing. Okay, we can update 2 different columns at the same time. Okay, in a given row, write same thing, update students, set, for example, first name equals to, for example, Chris, and also we change the date of birth to another date equals to, for example, 1998, for example, 11 and 1, where student ID equals to 5, equals to 5. If we execute that and we select all from students, so we get the first name and the date of birth with the new values. Okay, so this is using the update if you want to change a value in a given row. So we can also create or duplicate a table. So write create table, call it new students as, okay, so select all from students. Okay, now if we execute that and refresh our databases, so we have a new students table. Okay, and if we select all from new students, select all from new students, we get exactly the same values. Okay, new students, we get the same table. All right, and if we copy and paste that, okay, so we have the same values. Okay, now if we want to drop and delete completely a table, we use the drop command. Okay, drop table new students, and if we execute that, the new students will be dropped, so it will be completely deleted. Right, now if we want to only delete the data within a table and leave the table as it is with the columns and the data types, the constraint, etc., we can use what we call truncate. Okay, so now we are going to recreate the new table. So create table new students as, select all from students, and if we refresh that, so we have new students table. Now if we want to delete only the data inside the new students table without deleting the table completely, we can use the truncate command. So we write truncate table, and we select the name of the table, so new students. Okay, and if we execute that, so we select all from new students, you will see only the names of the columns, but we don't have all the data. So the difference between truncate and drop is that drop will delete completely the table and the data in it, but the truncate will only delete data inside the table, but it will not delete the table completely. So we have the names of the columns and the data types are left. Okay, so now for example, there is another command that we can use when working with tables, which is called view. So view is a command that we use in order to select some columns and to create a sort of a new table that we can call and display only the selected columns. And to give you an example, we are going to use the database, so Scikila database that is given. So use Scikila, right? We execute that. And for example, we select all from actor table, right, to see what do we have. So we have actor ID, first name, last name, and last update. For example, if we want to create view, so we call create view. So we give it a name, for example, let's say Davis, right? So we will select or we create another table with all the names that have a last name Davis as. So we select the columns. So we select first name and last update. Okay, so from the actor table, where, as we have said, last name will equal to Davis, right? Semicolon. So we create our view, and if we go to here, so we have our views. We refresh, so we get Davis view. Okay, and if we select all from Davis, right, we get our view, right? So here we have created a view which is called Davis, and it will select for us first name, last name, which will be displayed as new table where the last name is Davis. Okay, to drop a view we use the same syntax, right? Drop view, and we write the name of the view, so Davis. If we execute that, so we see that Davis view does not exist anymore. Okay, in this tutorial we are going first to start with alter command and to add some columns, to drop a column, to rename a column, add and remove constraints. Then we are going to talk about the difference between select and select distinct. We will also talk about aliases and about the operators. So to start, we are going to create a new SQL tab. We are going to create a table. Okay, right, create table customers, right? So it will have customer ID, which will be an int. We will also have first name, which will be varchar, okay, and it will have like 30 characters. We'll have last name, so same thing, varchar 30, and we'll have age, okay, which will be an int. So create our table, and if we refresh, so we get here our customers table, okay, which will have customer ID, first name, last name, and age. Here I didn't change the or create a new database, so it is added directly to the Scikila database, but you can create a new database and create this new table inside your database. So this is just a demo, it will not impact our database. So first, if we want to add a new column, we use alter, right, table, customers, and you write here add column, we call it for example test, and it will be for example int. Okay, if we execute that and if we refresh our table, so we have test, a new column added to our table. If we want to remove, okay, we write alter table customers, drop colon, and we write our colon. Okay, so if you execute that and we refresh, so the colon is deleted. Okay, for example, if we want to rename a colon, we use alter table, so we have customers, and we write rename colon. We have, for example, the age to, for example, customer age. If we execute that and we refresh, so the name is changed to customer age. We can also modify the data type of a column. To do that, we write alter table customers, and we write modify. We write the column name, which is, for example, we stay with customer age, and we write the new data type. For example, we say double. Okay, so just to show you how to change the data type. Okay, and if we execute that, and if we want to check, for example, if the data type is changed or not, we can use the show command. So we write show create, and we write table with the name of our table, so customers. Okay, if we execute that, so we will have the following. If you put your cursor in here, so you can see that the customer age is double with default null. Okay, and as you can see here, customer ID is an integer. If we change it to int, okay, so write integer, we execute that, we do the same thing, so we execute, and we can see that the customer age is an integer. For example, if we want to set the customer ID into not null, so we add the not null constraint, we can use the following. So we write alter table, we have customers, okay, we write modify the name of the column, which is customer ID, which is an int, and we set it to not null. All right, if we execute that and we show our table, okay, so as you can see here, we have not null constraint is applied to customer ID. Same thing, if we want to modify that, we write alter table customers, modify customer ID, and we remove the not. Okay, we execute that, we then execute our show, and it will be to null. All right, so we'll put it back to not null, we execute that, and we show our table. Okay, so it is not null. Same thing for example, the first name column. If we want to change the null default into a given character, we can use the following. For example, we can write alter table, so customers, and we write alter column. Okay, so the name of the column, which is first name, and then we use set default, right, into, for example, nothing. Okay, if we execute that and if we show, since we don't have anything, so the default is nothing, so it is changed from null to nothing. Okay, same thing if you want to add the check constraint, so we can use the following. Same thing, alter table, so we have customers, and we use add constraint, so we write the name of the column, which is customer age, and we write check. For example, we want everybody to have an age that is greater than 18 years old. For example, customer age is greater or equal than 18. Okay, so if we execute that and show our table, so we can see here that the constraint has been added. Okay, customer age constraint, okay, customer age check, customer age greater or equal than 18. Okay, now if we want to insert data to our table, so insert into customers values. For example, the ID is 1, we just add some characters in here, And if we put, for example, 12, okay, which is less than 18, we execute that and we see the output, okay. So insert into customer ID, error, check constraint is violated, okay. So here it will say to us that the value is not correct because you did not respect the condition. If we want to drop the constraint, okay, so we can write alter table customers, same thing, and we write drop constraint from our customer age. We execute that, and if we show our table one more time, we can see that the customer age constraint does not exist anymore, okay. We have customer age int default null, okay. So this is about adding and dropping constraint into our columns in a table. Now we will talk about the select and the select distinct and also the aliases. So to do that, we are going to create another tab, okay, and this time we are going to use the, for example, the film table in the Sakila database. So we can use Sakila, okay, and if we select, for example, all from, let's say, the film table, so we'll have the following. So we'll have all of the table in here, so it is present. Let me just put it like that, okay. And here we have select all. So as we have said, the asterisk means all the columns, okay. So we have here all the columns. Select, for example, only the title and the rental duration. For example, we can write title, comma, rental duration, okay. And we will have only two columns, so rental duration from film limit 10. So we'll have an error rental duration. We execute that and we get the following, okay. So we have our title and our rental duration, okay. We can select only the rental duration, same thing, and the distinct. So the select distinct is used to remove duplicates. So it will select only the different values that exist in the column, okay. For example, if we select distinct rental duration, so here we have only the different values, so we don't have duplicates, okay. So select distinct is used to remove duplicates in a given column. Now if we want to select these values and give it temporary name, we can use an alias. So we select distinct rental duration as distinct, call them for example distinct values from film, and if we execute that, the temporary name will be changed, okay. So this name is used only when executing this query, and it will give us the name of the column as distinct values without the duplicates, okay. So to use an alias, we use as like this, and we write the name, the temporary name that we want to use, then we execute our query, okay. So as we have said, select is used to select given columns, distinct is used to remove duplicates, and aliases are used to give temporary names to our results displayed in a given query. Okay, now let's talk about the operators, all right. For example, we can start by the comparison operators. So to do that, we can work with the same table. So we write select all from film. So here we have our table. For example, we want to select title from film where rental duration, for example, equal to 6, right? Okay, so we select all the title from film where rental duration equals to 6. We can also select the title and the rental duration to confirm that we have 6, okay. We execute that one more time, so we have only 6. Now if we want to select rental duration greater than 6, so all the titles which have rental duration greater than 6, So we have here 7. Same thing, greater or equal than 6. So we have 6 and 7. Same thing, we can select less than 6. So we have all the values which are less than 6, less or equal, okay. And we have different. So different is written like this. So we select all the titles where rental duration is different than 6, which means that we have all the values but 6, okay. So we have the comparison operators are as follows. We can write them here. So we have equal, greater, greater or equal, we have less than or equal, and we have different, okay. So these are the comparison operators. So in this tutorial we are going to talk about the logical operators. We are going to talk about the in between keywords. We will also explain the different aggregation functions that we use in SQL. We will use group by, having, order by. We will also work with wildcards and like operator. We are going to use the limit operator, and we will finally talk about the case statement. So to do that, we are going to create a new tab, and we are going to use the word database, okay. So we click use word, right, and we are going to use the country table. To explore the table, we are going to write select all from country, right, and we are going to have the different columns. So we have the code, the name, the continent, the year of independence, the population, life expectancy, etc. Okay, so we have here different things, and we are going to start with the logical operators. So the logical operators are the and, the or, and not. So we are going to start with and. For example, we want to select countries that are in Asia and have population greater than 100 million, okay? To do that, we write select name from country where. So here we write one condition. If we want, for example, continent equals to, for example, Asia, right? So we are going to have our table, okay? So we have all the countries that are in Asia, right? And, okay, and population is, for example, greater than 100 million, 100 million. We execute that, and we have the different countries, okay? For example, if you want to add the population, okay, so we are going to see the population and the name of the country. Thus, we can conclude that the AND operator will give us result if both the operands are true. Okay, so if country is Asia and population is greater than 100 million, it will give us result. If one of the operands, so the conditions, is false, for example, if we are going to put a country that it is both located in Asia and in Africa, for example, okay, which is not true. For example, Africa, we will have an output which is null. So we will not have any results because one of the operands is false. Okay, and as we have used, so we can use the one condition, for example, which is a character, and the second, which is an integer, right? For example, we can also perform the common use logical operators. For example, select 1 and 1, so it will give us 1. Okay, so 1 and 1 give us 1. 1 and 0 give us 1 and 0 give us 0. 1 and null, it will give us null, and 0 and null, it will give us a 0, right? So this is about the AND operator. Now we'll have the OR operator. So for the OR operator, one condition is enough. For example, as we have written before, for example, the country is in Asia or it is in Africa. So for example, if we are going to copy and paste that, and in Africa, right? So it will give us all the countries. Thus, we can conclude that the OR operator will give us true, will give us results if one of the conditions is true. So either the country is in Asia or in Africa. So we will have the result, right? So the difference between the AND and the OR is that for OR, one condition needs to be true, whereas for AND, both the conditions need to be true. Same thing, we can use the common logical operators. For example, if we select 0, null, so the result it will be null. So 0 or 1 it will give us 1, 1 or 1 give us 1, and null or 1 it will give us also 1. Okay, so this is about and or. Whereas for the not, it will give us the opposite of the condition. For example, if we want to select name, population from country, right, where population is greater than 1 billion, for example. And if we select that, we'll have China and India. If we write not, so not population is greater than 1 billion, which means that the population is less than 1 billion, and will give us all the remaining countries. Okay, so this is about the not operator, so it will give us the opposite of the condition. Okay, if the condition is true, it will give us a false. If it is false, it will give us true, right? Now we can also combine, for example, and or operators at the same time. For example, if we want to select name and population, okay, from country, okay, where, so here we can combine both operations. For example, we have to use parentheses, right? So we have continent equals to Asia, right? Or the continent is Africa. Okay, so this or condition will put it between parentheses, and we have population is greater than 100 million, for example. Okay, 3, okay, and we're close. So we are going to change continent. Okay, so I'm going to change continent, right? If we execute that, we're gonna have the name of the countries and also the population. If we want to add the continent, okay, so we add continent. We execute that. Continent, right? Okay, so we will have Nigeria in Africa, and all the main countries are in Asia, right? Now, if we remove the parentheses and we execute that, so we will have all countries. So it will select for us all the countries in Asia, okay, or in Africa, and the population is 100 million, okay. So if we want to use the or condition before the and, we're going to use it between parentheses, okay, and we execute that. We will have the continent is Asia or Africa, and the population is 100 million. So this condition will be applied on both the continents, okay? Whereas if we omit the parentheses, it will be only applied on Africa and not in Asia, right? As we have said, okay? So if we remove that one more time, we execute. As you can see here, for example, for the Armenia, it does not exceed 100 million people, and it is displayed, okay. So it will be applied only on Africa, okay. So this is about the logical operators. Now we'll talk about the in operator. So as we have said earlier, for the or operator, it will give us result, or we will have true if one of the operands is true. Well, the in operator will allow us to retrieve data if a given value exists in a defined list. For example, rather than using or statement 3 or 4 times, we can create a list, use the in operator, and use the condition. For example, if continent is in Asia, Africa, or Europe, give me the name and the population of the country. For example, we can write select name and population, okay, from country where, so we can write continent equals to Asia, okay, or the continent equals to Africa, okay, or the continent equals to Europe, for example, okay, and we execute that. So we'll have the following results, okay. The in keyword will allow us to create the following list. For example, we're gonna omit all that, so we create a list which is as follows. So we have the list is Asia, Africa, and Europe, where continent in the list, right? So if you execute that, we'll have the same result, okay. We have also between. So between is used to define a range, okay. For example, we can select the same thing, so we're going to copy and paste that, okay, copy and paste, right. For example, where population, we are going to define a range between, for example, 50 million and 100 million, okay. We execute that. So we are going to have all the name of the countries with their population. We can add, for example, the continent, okay. So here we have the different names of the countries that have the population which is between 50 million and 100 million. So between is used to define a given range. We start by the minimum value and the maximum value. Now we have also the aggregate functions. So the aggregate functions are the following. So we have the average is defined as follows. We have the mean, which is the minimum. We have the max, which is the maximum. We have also count, and we have the sum, okay. For example, if you want to select, so I'm going to select all the columns, okay. Here we have all of our columns. Now, for example, if we want to select the max life expectancy, right, max life expectancy, okay, so we have the maximum, and if we select the minimum, right, okay, we can select it as minimum, right. We can also select the average, for example, as average. So we have the average. We can select the total countries. For example, we have can select count, right? Count. And for example, we have name as total countries or total, okay. We execute that, so we have 239, and we can also select the sum, okay. So for example, the total population in the world, okay, sum of population, okay. So we have the sum of the population. We can also give it a name, for example, total population, okay. So we have our alias, which is total population, and if we execute that, as you can see, check the manual, okay. So you have to define your names or your aliases without the spaces between the words, okay. So if we write that, we have the total population, okay. So this is about the aggregation functions, which are the average, the minimum, the maximum, the count, and the sum. Now we'll talk about the group by. So group by is used to define groups that have the same values. Okay, for example, we can define the total population in a given continent. Okay, for example, we can write select continent. Okay, sum of the population. Okay, from we have our table. Okay, and we are going to group that. So group by continent. So as you can see here, we will have the different populations in each continent. For example, North America, Asia, Africa, Europe, South America, etc. Okay. Now, if we want to sort these values, for example, from the highest to the lowest or from the lowest to the highest, we can use the order by. Okay. So order by is used for sorting. So we use first the select statement. We select our columns from our table. We are going to group that by continent, so the sum of the population in each continent. Then we are going to order that, so order by, for example, the sum of population. By default, it is ascending, so it will be from the lowest to the highest. Okay, so if we are going to omit that, the ASC, for which stands for ascending, it will give us the same result. Now, if we want to display it from the highest to the lowest, we can use DESC, okay, which stands for descending order, and it will give us the highest to the lowest from Asia, Africa, and Europe. Then, if we want to select the, for example, the top three, we use the limit keyword. So limit, and for example, you write 3, okay? So here we use the limit keyword to select the total rows that we want to display. Okay, for example, if we want to select the highest, we select limit equals to 1. Okay, now for example, if we omit the limit, okay, and we add the condition, so as we have said, we write the select from, then we have the condition. So this is the order where, for example, let's say the sum of population is, for example, less than 700 million. Okay, if we execute that, so we will have an error. Okay, because we cannot use where clause with aggregation functions. Okay, and if we want to add this condition, we use the having keyword. So having keyword is used to set conditions that are defined using aggregation functions, because the where clause does not allow to do that, and we have to define having after the group by statement. So if we cut that, we can add it after the group by having. So we write having the sum of population is less than 700 million. Okay, so we have our result. Okay, so having is used to define a condition that depend on aggregation function, because where clause does not allow to use that. Now we'll talk about the case statement. So case statement is used when we want to define categories depending on some conditions, and as a result we will get a new column with the defined categories. For example, we can define a case statement in here. So for example, we can select name, for example, population, and third column. Okay, as we have said, the categories will be defined in the third column. This third column will be defined depending on conditions. Okay, so we write case when population, for example, is less than 50 million, then we will define a string that says population is less than 50 million. Okay, just an example. Another condition, when population between 50 million, for example, and 100 million. Then we define a new string. We say population is between 50 million and 100 million, for example. Else, so if the first condition is not satisfied, we go to the second condition. If the second condition is not satisfied, we go to the else statement. So else, we say that, for example, population is greater than 100 million, okay, as a string. So we write and as population, for example, category, and we add the table. So we have said from country table. Okay, so here we select the first column, the second column, the third column will be as a case statement. It will be named population category and it will depend on conditions. So if population is less than 50 million, population between 50 and 100, else we have this string that will be displayed. Okay, now if we execute that, we have the first one, it is less than 50. They are all less than 50. Here we have population greater than 100 million, population between 50 and 100, etc. So the third column is defined using the case statement that depends on the conditions also defined on the population. Okay, so we write case, we go to the first condition. If the first condition is satisfied, so we write population is less than 50 million. The first condition is not satisfied, we go to the second. So population between 50 million and 100 million, we say that population is between 50 and 100, okay? If the first and the second condition are not satisfied, we go to the third one, which is greater than 100 million, okay? So population is greater than 100 million, okay? So this is about the case statement. Now we'll talk about pattern matching. What we mean by pattern matching is that when we want to define a condition on strings, for example, we want to select words that start with A, words that end with Z. So generally, if we want to search for a specified pattern, and this pattern obviously needs to be a string, we can use two different methods. We can use the like keyword, or we can use regular expressions. When we work with the like keyword, we have two common signs that we use. So we have the underscore and we have the percentage. So for the underscore, matches exactly one character, okay? And we have the percentage, which can match, so matches any number of characters, okay? Even 0 characters, okay? So this is multi-line string, okay? And for example, if we want to work with the city table, okay? So right, select all from city. We have the different names, okay? Now, if we want to select all from city, where, name, and for example, if we want to select names that have exactly 5 characters, so we write like, a string, and as we have defined in here, the underscore matches exactly 1 character. So if we want to display names with 5 characters, so we put 5 underscores, 3, 4, 5, okay? If we execute that, so we'll have only the series with names that have exactly 5 characters, okay? For example, if we want to look for names that start with C, so we write C, and it can have any number of characters after the letter C. So one condition is that the word or the name needs to start with C. We execute that, so we have all the names that start with C. It is the same thing if we write C in the lowercase or in the uppercase. So we'll have exactly the same results. All right. So same thing, if we want, for example, to select names that start with C and have exactly 4 characters, so we have to omit the percentage and we add 3 characters. So we have the C and 3 other characters. So here we have names that have exactly 4 characters. Okay? We can also use the percentage, for example, any number of characters. So we select names with any number of characters that end with T. Same thing. So we have all the names that end with T, and we didn't specify exactly the number of characters. If we want, for example, to have 5 characters words, we can add 4 underscores. So 1, 2, 3, 4. So we'll have names with 5 characters that end with T. Okay? Same thing. If we want to select, for example, names that start with C and end with T, so I write C percentage T, and we will have all the names that start with C and end with T. Okay, so if we write C percentage T, it means that the word starts with C and ends with T. Same thing, if we want to know, for example, words that contain, for example, TH in the middle, so we write percentage TH percentage, we execute that, so we'll have all the names that have TH in the middle. Okay, so it can be in the middle, it can be in the beginning, or it can be at the end. Okay, so we didn't specify, we just want names that contain TH. Same thing, for example, here we have selected names that have TH. If we don't want to display names that contain TH, we can add not. So not like TH. So here we will have all the names that do not have TH in their characters, okay? So not like, it means that all the names that are selected here do not have TH. So this is about the like operator for pattern matching. In this tutorial, I'm going to talk about union and union all. So the union operator is used to combine the result from 2 or more select statements into a single resulting set. By default, union operator removes duplicates. So if we want to retrieve data with duplicates, we use union all. And also, the column names for a union result set are taken from the column names of the first select statement. When we select the columns, the total number of columns need to be the same in all select statements. All the columns need to have the same data types, and the order of the columns need to be the same in all select statements. So to understand better union and union all, we are going to apply that using MySQL workbench. So to do that, we are going to use the Scikila database that we have in here, and we are going to use 3 different tables. So we have the film actor, the film category, and the film tables. Okay, so first we write use Scikila, right? Since we are going to work with the Scikila database, we execute that. Then, as you can see here, for example, from the film actor, we have different columns. So we have actor ID, film ID, and last update. And the same thing in the film category, we have 3 different columns. So we have the film ID, category ID, and last update. So what we are going to do, we are going to select the film ID and the last update from the 2 tables using the union. First of all, as we have said, the number of columns needs to be the same, the data types needs to be the same, and also the order needs to be the same. So write select film ID, last update from. So we'll start by film actor table, union. So here union, we are not going to use, or we are not going to retrieve duplicates, and we write also select film ID, not field but film. So here film ID, and we write the same thing, film ID, last update, same thing from film category table. Okay, and we execute that. So here we have different film IDs and last update. So we have said that the names of the resultant table are the names of the columns, so we can use an alias. So select film ID as film. For example, we can write film, okay? and if we execute that, so we'll have film. All right, so we can use an alias to define the name of the resultant set. And as we have said, if we want duplicates, we can use the union all. So we write union all, we execute that, and to have a clear result, we can order by. So order by, since we have changed the film ID into film, so we write film, we execute that, so we can see here the duplicates. Okay, so we have a lot of ones, and if we write only union, we execute that, so we'll have only the different rows. As you can see here, the time is different from the film ID 1 and the film ID 1 in the second row, right? Same thing, for example, here if we add another column, so the first one has 2 columns, the second one we will have a third column, for example, which is from the film category, which is category ID. So we'll get an error. Okay, select film ID, error, because we don't have the same total of columns. Same thing, for example, if we want to add another table, so we write union, select film ID, and in the film table we have also other columns. As you can see here, we have the film ID and we have a last update, so we can add last update from film, order by film. Okay, we execute that, we get the same thing. We have the 3 rows are different, even though they have the same film ID, but last update is different. Okay, same thing if we use union all. Okay, we will get duplicates. Okay, we can also use a where clause in our queries. For example, if we want to select only the last update and the film ID from the film actor table, where, for example, film ID, okay, equals to 1. Okay, let's say we want film ID equals to 1, and we remove the duplicates. Okay, so as you can see here, in the first 3 rows we have film ID equals to 1 for the 3 tables, but starting from the second, okay, so film ID equals to 2 for film category, and the other 2 is for the film. Same thing, we can use the where clause in the second table and in the third table. Okay, if we execute that, we will get only the film ID equals to 1 for the 3 tables. Okay, so we can use where clause, we can order by column, and as we have said, we have the total number of columns needs to be the same, the order needs to be the same, and data types need to be the same. So union is used to remove duplicates, whereas if you want to retrieve the duplicates, we use union all. So in this tutorial, we are going to talk about MySQL joins. So joins are used to combine rows from 2 or more tables depending on the related column between them. There are 4 types of joins. We have inner joins, outer joins, natural joins, and cross joins. For the inner join, which is also corresponds to the intersection, so the inner join keyword selects the rows that are in both tables, which means that it retrieves the intersection of the tables. As you can see here, for the blue area, it represents the intersection between table 1 and table 2, which means that the inner join will display for us the rows that are both present in table 1 and in table 2. For the left outer join, which is also called left join, it returns all the rows from the left table, which is table 1, and the rows that match from the right table, which is table 2. So if we have rows in table 2 that do not match the rows in table 1, they will be displayed as null values in the corresponding columns. Same thing for the right outer join, which is also called right join. It returns all rows from the right table, so table 2, and the rows that match from the left table. So same thing, if the rows in table 1 do not match with values in table 2, so they will be displayed as null values in the corresponding column. And we are going to display that when we go to the hands-on. For the full outer join, it retrieves all the rows from table 1 and table 2. So null value will be displayed in the columns of the first table if there is no match. And same thing, null value will be displayed in the columns of the second table if there is no match. In MySQL, there is no keyword for full outer, so we will use union. Now we have right outer join with null values. So it retrieves rows from the right table, which is table 2, that do not have a match with rows from the left table, which is table 1. For example, for the normal right outer join, we display all values from table 2, which is the right table, and the corresponding values in table 1. So if there is no match, we will have null values. For the right outer join with null values, we will display only the rows in table 2, which is the right table, that do not have a match in table 1. Same thing for the left outer join with null values. So it retrieves rows from the left table, which is table 1, that do not have a match with rows from right table, which is table 2. And same thing, we are going to understand that better when we go to the hands-on. Now we have the full outer join with null values. So as you can see here, it is the sum of the right outer join with null values and the left outer join with null values. So it retrieves rows from the left table, table 1, that do not have a match with rows from right table, which is table 2, and also it retrieves the rows from the right table, which is table 2, that do not have a match with rows from the left table, which is table 1. As you can see here, it is the opposite of the intersection. Now we have the cross join. So the cross join, it maps each row from table 1 to all rows from table 2. For example, if the total rows in table 1 equals to 3 and the total rows in table 2 equals to 3, then we will have a total of 9 rows as a result, which corresponds to the Cartesian product. For natural join, natural joins merge two tables based on the columns with the same data type, without specifying the column using on keyword like in inner join. So as we have seen in the inner join, we have to specify the column that we want to use to join the two tables. Whereas for natural joins, it will be done automatically and it will choose the columns with the same data type. And we'll understand that better when we go to the hands-on. Okay, so to understand that better, we're going first to create a new database. So we write create database and we call it joins. We execute that. We refresh to see the database. So it is in here. It doesn't have any table, so we are going to use our database. So we write use joins, which is the name of our database. Then we create our first table. So we write create table and we call it table 1. It will have two columns. The first column, it is called ID and it is an integer. And the second column, we call it name1 and it will be varchar. So it is a character, right? So we create the first table. Then we create the second table. So we write create table. We name it table 2. So it will have only one column, which is a character. So we call it name2 and it is varchar, right? So create table 2. Then we create a third table. So write create table 3 and also it will have only one column, which is an integer. Now for the first table, since we have two columns, so we insert values. So write insert into table 1 and we have one column for the ID and the second column for name1. So here I choose arbitrary names. You can choose any names that you want as long as it is a character. So we insert the values into the first table. We retrieve all the rows. So we write select all from table 1. So here we have all the rows from the first table. So we have ID and name1 and we have 4 rows. The first column is an integer and the second column is a character. Same thing, we insert to table 2. As we have said, we have only one column. So we execute that. Right, insert into table 2. We have the values. So same thing. Here we have the first row matches the first row and also for the last row it matches the last row. Whereas for the second and the third, they do not match, so they are different. So select all from table 2 and we have our rows. So we have one column and 4 rows. The first one and the fourth, they match with the first table, whereas for the second and the third, they do not match. Here, the table 3, we are going to add 2 values. This table 3, we are going to use it in natural joins, so we'll use it later on. So we insert values 1 and 4, same thing. Table joins 3 doesn't exist, so we didn't click here. So create table 3. Okay, now we will insert the values to table 3. Okay, and select all from table 3. So here we have 1 and 4, which equals to 1 and 4 from table 1. Okay, so here we have our 3 tables. If we refresh in here, so we have 3 tables. We have table 1, it has 2 columns. We have table 2, which has only one column. And we have table 3, same thing, it has only one column. Now, we start by the inner join. So as we have said, if you want to select, for example, you can select all, or you can write here the names of the columns that you want to select. So we select all from table 1. Okay, so the left table is table 1 and the right table is table 2. Okay, so we select all from table 1, inner join. Okay, so we create a join between table 1 and table 2, so it is an intersection. On, so from table 1 we choose the column that is named name 1, and in the second table we choose the column that is called name 2, so they have the same data type, and we use that using the on keyword. Okay, so right, select all from table 1, inner join table 2, so we join table 1 and table 2. On, the column from the first table is name 1 and the column from the second table is name 2. So here we select the intersection. As we have said, we have the first and the fourth rows that are the same. Here, since we selected all, so it will give us all the columns. But for example, if you have a table that has 20 columns and the other one it has 19 columns, you can, for example, write here the names of the columns, for example, ID and name 1. Okay, for example, you can select only ID and name 1, or you can write all. Okay, so it depends on the task, right? So here we have the inner join, we don't have the null values, and we have the intersection, which means that we have the rows that exist in both the tables. Same thing, now we execute the left outer join, so right select all from table 1, so table 1 is the left table, and we write left outer join table 2, so we create left outer join between table 1 and table 2. On, same thing, we choose the column. Okay, for the first table it is name 1, and for the second table it is name 2. So once we execute that, we will have all the rows from the first table, which is the left table. Okay, so we have here A, B, C, D, E, F, so we have all the rows. We have also the corresponding rows in the right table, okay, which is table 2, A, B, C, and KL. But if we don't have a match, it will display for us the null values. Okay, so we write select all from table 1, which is the left table, left outer join, so we'll write left outer join, table 2, which is the right table, on, and you write here the columns. So for from the first table we choose name 1, and from the second table we choose name 2. So it has selected for us all the rows from the table 1, the corresponding rows from the second table, and for the values that they do not match, we'll have null values. Okay, same thing for the right outer join. So if we execute that, we will have all the values from the right table, which is table 2. So we'll have here all the values because we have chosen name 1 and name 2 as the columns that we use for the join. Okay, so right select all from table 1. Here also you can choose the columns that you want. Right outer join table 2, so we select all the rows from table 2, they are in here, and we select the corresponding rows that match from the first table. If they do not match, we put the null values. Okay, so automatically it will give us null values. So this is for the right outer join. It displays all the rows from the right table, which is table 2, and the corresponding values in the left table, which is table 1. So we have here the values. If we do not have a match, we display null values. It will be displayed automatically. Now, as we have said, for MySQL, we do not have the full outer join, so we are going to use union. So as we have said, union does not display for us or does not retrieve for us duplicates. Okay, so here we display the values that are in here in the first one, left outer join, and we use union with the right outer join. Okay, so that we get the result. Okay, so we display that. So here we don't have any duplicates, right? So we have matching values, and we have null values and null values. Okay, so here we don't have the duplicates. Same thing, we write select all from table 1, which is the left table, inner join table 2, which is the right join, on. So we have selected the columns for the join. Union, same thing, we select all from table 1, right outer join, table 2, and we select the same thing, the columns. Now, if we want the full outer join with duplicates, so we use union all. Okay, so as you can see here, we'll have duplicates. For example, we have ABC, ABC twice, ABC, ABC twice, and same thing for ID equals to 4, we have it twice. Okay, so here we have duplicates. So if you want to retrieve rows without duplicates, you use union, and if you want to retrieve duplicates, you use union all. And as we have said, MySQL does not have full outer join keyword, so we have used union to union the left outer join and the right outer join in order to get our full outer join. Okay, now for the cross join, we have said that we do not use the on keyword, so it will be a Cartesian product between the first table and the second table, which means that it will map all the rows from the left table to the rows in the right table. Okay, so if we execute that, we'll have the following. So we'll have 4 times 1, 4 times 2, 4 times 3, and 4 times 4. So since we have 4 times 4, we will get 16 rows. Okay, and we have used here the order by, so we wanted to order by the table1.id. Okay, in order to get a clear result. So here, as you can see, for the cross join, we don't use the on keyword, so we don't specify the column that we want to use for the join. Okay, so it will be done automatically since it will link all the rows from the left table to the rows in the right table. Okay, so right select all from table, cross join table 2, so create a join between table 1 and table 2 without specifying the name of the column. Okay, now as I said, I created table 3 to use it for the natural join. So same thing for natural join, we don't use the on keyword to specify the name of the column. Okay, and we write same thing, select all from table 1, natural join table 3. So as you can see here, it will automatically link the ID of the first table and the ID of the third table. Okay, it did not choose the name 1 because it is varchar, and it chose ID since it is an integer. So for the natural join, same thing, we don't use the on keyword to specify the name of the column, and it automatically chooses the column that it will use for the join depending on the data type. In our case, it is the ID column, which is an integer. Okay, now for the left outer join, okay, so we select all from table 1, left outer join table 2 on table 1. So this is the same thing as the left outer join. Okay, but we want to select, so we use the where keyword, table2.name2 is null. Okay, we want to display the rows from the first table that do not have a match in the second table, so which means that table2.name2 is null. Okay, so here we display only the null values, so we have the second and the third columns, they do not have a matching value in table 2, which means that name2 is null. Same thing for the right outer join. If we execute that, we'll have the same thing. So we have said that for right outer join, it will display all the rows from the right table, and if there is no match in the left table, it will display for us the null value. But here we want only to display the null values, so the rows in the second table that do not have a match in the first table, which is the left table. Okay, same thing for the full outer join in MySQL without duplicates, if null, opposite of intersection, which means that in the first case we have created the left outer join union right outer join to create the full outer join. Here we do the same thing, but we display only the null values. Okay, so the rows that do not have a match in each table. So the first 2 rows in here correspond to the left outer join with null values, and the last 2 rows is about the values in the second table that do not have a match in the first table. In this tutorial, we are going to talk about MySQL subqueries. So basically, a subquery is a query inside a query, which is also called nested query. The query contained in the subquery is called the outer query and can be select, insert, update, and delete. The subquery is called the inner query, and it can be used within select, from, and where. The subquery, which is also called the inner query, is executed before the outer query. And of course, the subquery needs to be used within parentheses. So here we have the syntax of the subquery. We have the outer query where we select the columns from a table. So here this example is subquery used within the where clause. So in the where clause we define our condition, then we open parentheses and we define our subquery. So we can select columns from table, we can retrieve single value, we can retrieve list of values, etc. There are 6 types of subqueries. We have the subquery as scalar operand, subquery in from clause with group by, comparisons using subqueries, so where we use the comparison operators, subqueries with any, in, some, or all, correlated subqueries, and finally we have subqueries with exists or not exists. So the first type is scalar or column subquery. It returns a single value like the maximum, the minimum, the average, so it will be in one column, one row. Or it can return a column of values, so it can be used anywhere in a query where column can be used. And here we have an example using insert into. So for example, we create a table which we call city population summary, and we insert some values like the minimum, the maximum, and the average. As you can see here, all the subqueries are defined within parentheses. The second type is the subquery in from clause with group by. First, the inner query, which is the subquery, returns a temporary table with categories or groups created with group by. Then after that, we retrieve data with the outer query from the temporary table. An alias must be used to name the temporary table and the temporary column or columns. Depends on the task. Here we have an example. We calculate the average of languages used in the world by country. So in this example, we have 2 tables. We have the country table and we have the languages table. The first thing that we have to do using the subquery is to count the total languages in each country, and we give it a name as total languages. Then we calculate the average using this temporary table, and we will see that later on in the hands-on. The third type is comparisons using subqueries. So they are used within the where clause, and we use comparisons operators to retrieve data depending on the comparison with a single value returned by the scalar subquery. For example, we can return the minimum, the maximum, or the average. Here we have an example. We select the name and the population from a table which is called cities, where the population is less than the average. So we have a table which is city, and we want to select all the cities that have population is less than the average. So select average population from city, which is the subquery, will return a single value, and we compare the population of each city with this single value. The next type is subqueries with in and not in. So it is also used within the where clause, and the in operator will allow to retrieve one if any of the values in the list matches. In this example, we have the customers who did not pay. We select all the customer ID from the payment table, so all the customers that have paid, and we check. So if the customer ID not in this list, it means that they did not pay. If all the customers have paid, this will return an empty list, and we will see that in the hands-on. Next, we have subqueries with any or some. So returns one if any of the values in the list satisfies the condition. It is also used within the where clause and must follow a comparison operator. As we have seen for in, we don't need to use any comparison operators, but with any or some, we have to use the comparison operators. And one small remark is that some is an alias for any. So if you use any or some, it is the same thing. So here with the subquery, we select customers that have addresses with 4 digits postal code. Then we select all the names of the customers with this ID. The subquery, we select for us all the postal codes with 4 digits. Then we use this list to select all the customers that have these addresses. Next, we have subqueries with all. So all returns 1 if all the values in the list satisfies the condition. It means that no single row has to be false. So everything needs to be true. Otherwise, it will return false. Okay, it is also used within the where clause and must follow a comparison operator. Same thing, here we have the same example like the any, but we use all. So return true if all zip codes have 4 digits. As we will see, there are postal codes which have 5 digits. Thus, not all the values in the address ID list are with 4 digits. As a result, when we use all, it will return for us an empty list. Next, we have correlated subqueries. A correlated subquery depends on the outer query, which means that it contains a reference to the table that appears in the outer query. As we see here in the subquery, which is between parentheses, we add the column which is called address ID as a reference to the outer table. So here we use the condition where postal code is less than 10, and we add our reference, which means that this subquery depends on the outer query. And this is why it is called correlated subquery. Finally, we have subqueries with exist or not exist. So it is also used within the where clause. Exists return true or false. It returns true if the subquery returns at least one row. If the resultant set is empty, it returns false. And here, one small remark is that the selecting columns in the select statement of the subquery do not matter. For example, here, as we can see, so we have select all from customer C, where we don't write any columns, so where exists, we use directly exists after the where. We open our parentheses, so when we select the address ID or we select all or we select 2 or 3 columns, it is the same thing, because exists will look at the retrieved data. If we have at least one row which is true, the exists returns true. Otherwise, it will return for us false. And not exist is the opposite of exists, and generally it is used with correlated subqueries. So when we use exists or not exists, we generally add the reference to the outer subquery. So to understand that better, we are going to apply that using MySQL workbench. Okay, so to start, we are going to use the world database. So we write use world, okay. And as you can see here, we have 3 tables. So we have the city, the country, and the country language. For example, if we select all from city order by population, so we have the different names of the cities, the country code, the district, and the population. What we wanted to do is to first work with the scalar or the column subquery. So first we are going to create a table that we will call city population summary, and we will add 3 columns. So the first column, it is the minimum population, the maximum population, and the average population. The 3 columns will have data type which is a float. Okay, so we create this table. Then we want to insert into our city population summary the different values using subqueries. So the first one is the minimum population from the city. So if we copy paste that, okay, so we'll have one single value. All right, is here. The minimum is 42. Now, as we have said, we can use the scalar subquery anywhere where column can be used. So as you can see here, this subquery returns a single value which is 42, and the same thing for the others. So if we write insert into city population summary, and here we will put all the values in the same order, so I didn't put the name of the columns. And if we execute that, so if we select all from city population summary, we will get the following table. So we'll get the minimum population. Okay, minimum population is this name, and it contains 42. The maximum is this one, and the average, we have the average population. Okay, so this is subquery as scalar operand. Now we have also said that it can return a column of values. Okay, so here we can select, so we have, if we put this alone, so we put select the average. So here we have the average, and if we want to add this value into all the rows, so we have a column of values, we write select all, we add this column, okay, as we call it average population from city. So if we execute that, we'll have the following. We have this column of the values which contain the average. So in each row it will add this value. So now it has no meaning, but there are some cases where you will be asked to add a column of values, for example as a reference. Okay, so this is about the first type. Now when we use subqueries for comparison, so here we have calculated the average. Okay, it will give us a single value. We are going to select the name and the population of the from the city table where the population is less than the average. So this is select average population is the so this is the subquery, and it has this following value. Now if we execute that, we'll get all the cities that have a population which is less than the average. For example, if we put equal, so we'll have nothing. If we'll put greater than, we'll get all the cities that have a population which is greater than the average. Okay, so this will return for us single value, which is the average. Then we will use comparison operator to compare the population. Okay, now we have the third type, which is subquery inform clause with group by. We are going to calculate the average of languages used in the world by country. Okay, so first of all, I'm going to select everything, select all from country, so that you will have an idea what do we have. Okay, so here we have everything in each country, and in the country table we'll have the code. All right, now same thing for select all from. So we have everything here, and as you can see here in the country language we have country code, and in country it is called code, right? So our subquery is defined as the following. So if we select the subquery, copy, and if we paste that, okay, it will give us the following temporary table. All right, so what we have done is we select the name in each country, we count the languages, okay, and we call it as total languages. All right, from country language, inner join. So since we don't have the name of each country in the country language table, so we inner join the country language with country on. As we have said, in country it is called code, and in country language it is called country code. We use group by country language country code, so I'm going to group that using the country code, and we order by the total. Okay, so our temporary table, which is the following table that we will get using the subquery, we call it temporary table. So we use an alias as temporary table, which is the following table. Here we are going to calculate the average of total languages. So it will calculate the average of this column as average languages by country. So it will calculate the average languages in all countries all over the world, and it will give us the following result. So we have on average 4 languages per country. Okay, so now next we have subqueries with any, in, some, or all. So first, as we have said, any and some are the same, so we can use any one that you like. And here we start with an example with in. Okay, so basically when using in keyword, we first define a list. For example, in this case, we want to select cities that have a country code that is not included in country table. Okay, so here in country we have different codes. Okay, so we have different codes that are defined in the country table, and what we want to know is if there are cities that have a country code that is not included in country. Okay, to do that we add not, so we have not in, and we execute that. So we'll get an empty list because all the cities that are defined in here have a country code that is included in country table. Okay, so as we have said, basically in and not in will check for a given value in the list. Okay, since here all the country codes that are defined for cities are included in country, so we'll get an empty list. Okay, next for any or some we'll use the Scikila database, so write use Scikila, and same thing in here, any will check if this list is empty, it will return false. If this list returns or has at least one row, it will give us the corresponding customers. Okay, so the select address ID is the subquery and it has the following values. So if we want to display the different values, okay, so we'll have all the address IDs where the postal code has 4 digits. All right, so the list is not empty, thus any will return true, and it will give us all the customers that have an address ID where the postal code is or has 4 digits. Okay, so here we have all the customers which have an address that has a postal code with 4 digits. Okay, same thing if we want to retrieve data that have 5 digits postal code, we can use greater than, and we have this list. Okay, as a result, when we use the all keyword for this statement, we'll get an empty list. Why? Because here we have postal codes that have 4 digits and others they have 5 digits. Okay, which means that the condition for all is not satisfied. This is why we get an empty resulting set. Same thing here, we have another example using in and not in, and here we want to select all the customers that did not pay. Okay, so we select customer ID from payment. Here we select all the customers who have paid. Okay, we have the list. Now we want to know the customers that did not pay. To do that, we check the customers with the customer ID that is not in the list. Okay, so if any customer has customer ID that is not in this list, it means that the customer did not pay. Okay, so here we have nothing. Okay, which means that all the customers have paid. Finally, we have correlated subqueries with exists and not exists. Here the same thing, we want to select all the customers from the customer table where the postal code has 4 digits or 3 or 2 or 1. So all the values of the postal code which are less than 10,000. Okay. Here the same thing, exists will return true if at least there exists one row in this list. Okay. So if we execute that, we will have more than one row, which means that when we execute, okay, it will return for us all the rows of the customers that have an address where the postal code has 4 or less digits. Okay, now if we remove the reference, so the query will not be anymore a correlated subquery. We execute that, so as we can see, it has retrieved all the customers. Okay, because it will select all from customer C. So here we have a list that has at least one row, which means that exist will return true and it will select all from customers. But if we add the reference, it means that it will depend on the outer query. Thus, when we execute this query, it will take in consideration only the addresses where the postal code is less than 10,000. Okay, as you can see here, we don't have all the customers. For example, if we want to use only 10, we'll get the following. So we'll get only one customer. But if we remove the reference, it will give us all the table because exists returns true. Okay, same thing if we use not exists, it will give us the opposite of exists. Okay, since we have true with exists, if we add not, it will give us a false, thus it will retrieve for us an empty list. In this tutorial, we are going to talk about two other types of joins, which are the self-join and the null self-join. These two types are frequently asked in interviews. So to do that, we start by the self-join. The self-join is defined as the join where the table is joined with itself. We are going to start with the self-join, so we are going to use the word database. Okay, so we are going to use a word, and the objective is to select the pairs of country names. Okay, the most important thing in the self-join is the aliases. As you can see here, we'll import data from the same table, okay, which is country table, and we use two different aliases. Okay, we will join country with country, but we are going to use different aliases. So we have C1 and C2. So we are going to see first what we have in the country table. Okay, so select all from country, and we have the following. So we have the name of the countries, we have the continent, the region, etc. So here we will have all the countries in Europe, and we will join them depending on the region. So we will have a region, and in each region we will have all the possible pairs. So we select C1.name, so the name from C1, which is country, and C2.name, which is also country but with different alias, which is C2. Then we select the region. So we'll have three different columns from, as I said, country and country with two different aliases, separated with a comma. Where? So the first condition, it means that we don't want duplicates. Okay, so we don't want C1 equals to C1.code. So we don't want the same name which is created with a pair with itself. The second condition, as I said, it will be in Europe, and it will be pairs within the same region. Then we are going to order by region. Okay, so if we execute that, we will have all the different pairs. So in the first region, then we have the second region, the third region, etc. Okay, now if we remove the first condition, which is C1 is different than C2, as you will see here, we will have duplicates. Okay, we have Estonia, and Lithuania. Okay, so we'll have the duplicates. So basically, the first condition means that we don't want to see duplicates, and we will order that by region. Okay, so this is the order, and of course, all the countries are in Europe. Okay, so self join, as I said, we will join country with country, but we will use different aliases. So the first one is C1, and the second one is C2. We can also select the pairs of countries using the second method, which is the cross join. Here we didn't use any type of join, so we have used the usual SQL keywords, select from where, but here we are going to use the cross join. By definition, the cross join, it performs Cartesian product, okay? And here we select, so C1.name, we give it a name as country1, C2.name as country2, and C1.region. So we have the same thing from C1, so country C1. As you see, we have the same alias, but we don't use a comma to select the second table. We will use the cross join. So we write from country C1, cross join country C2, where, so to remove duplicates, the continent is Europe, the second continent is Europe. So here, since we have used the cross join, we have to define the continent for the first table and the continent for the second table. And also we will have groups depending on regions. So we have all the pairs within each region. Same thing, we order by the region. If we execute that, we will have exactly the same results. As you can see here, we have exactly the same results. Okay, so this is about the self-join. So here we have seen two examples, but the most important thing is that you have to be careful about the aliases that you want to use, okay, because it is with these aliases that you will define your conditions, okay. So this is for the self-join. Now we'll talk about the null safe join. So the null safe join is used to handle and join null values. By default, when we use an inner join, it only selects values which are not null. So to look for the null values, we use two methods. We use either the is null keyword or the null safe operator. As we will see, the null safe operator performs an equality comparison like the equal operator, but it returns 1, which means true, rather than null if both operands are null, and returns 0 or false rather than null if one operand is null. For example, if we select 1 equal null, as a result we will have null. But if we select 1 with the null safe operator null, we will get 0. So if we only have one operand which is null, we'll get result as 0. But if we have both operands are null, we get a result as 1, which means that true. So if we have 0, it means false. If we have 1, it means true. Okay, same thing. Select 0 equals null, we will have null, and null equal null, we will have null. But null with null safe operator null, we will get 1. Okay, so to understand that better, we are going to use the joins database that we have created. Okay, you can click on the link above, or you can find the link in the description about the video about joins. So basically we'll insert in the first table new row, okay, with an ID equals to 5, and we will add null value. So if you select all from table 1, we'll get the following. So we'll have the previous 4 rows with characters, and the fifth value it will be a null. Same thing, we'll add another value to the second table so that we will have 5 rows in both tables, and we update. So the first row where name2 equals to abc, we are going to put a null value. So if we select all from table 2, we'll get the following. So we'll have 2 tables, each one has one null value. Now if we use the default inner join, okay, with an equal operator, so we select all from table 1, inner join table 2 on, so name1 equals to name2, right? So if we select that, we get only the row where the ID equals to 4, and we have the characters, so we don't have the null values. Now if we use the null safe operator, okay, which is a null safe operator b, by definition it is the same as writing a equals to b, okay, so we have the following, or a is null and b is null, which means that it will select for us the null values. Okay, so if we use the first method, we use directly the null safe operator, we'll get the following. So we'll have the null values. Okay, and same thing if we use the other method, which is a detailed explanation about the self null operator, okay, which is the following, we get exactly the same result, right? So we use the null safe operator, okay, which is this one, to handle null values when we join our tables, because if we don't use the null safe operator, if we use only equal, we'll get the result with only characters without null values. And as we have said, the first method is equivalent to the second method, which is by definition the null safe operator corresponds to the full expression written in here. Okay, in this tutorial we are going to talk about MySQL built-in functions, and more precisely we are going to talk about the 3 different types that are shown here. So we have string functions, numeric functions, date and time functions. So I'm going to start with string functions, and from the name we can understand that these functions are used with strings. Our first function is the concatenation functions, which returns concatenated strings. For example, if you have 2 different strings and you want to concatenate them, so you write select concat and you write your 2 strings. So if we execute that, we'll get the following. So we'll get one single string. Same thing if you want to concatenate the 2 strings and you want to add space between them. So you write select concat, you write your first string, you add space, then you write your second string. If we execute that, we'll get the space between the 2 strings. Same thing, you can increase the space and you get the following. Okay, so this is about the concatenation function. The second function is the left function, which returns the leftmost number of characters as specified. For example, you write select left, you write your string in here, then you specify the number of characters that you want to retrieve. So here we write this string and we want to get the 3 first or the 3 leftmost number of characters. If we execute that, we'll get the following. For example, we change it to 4, we'll get 4 strings. Then we have length. So length function returns the length of a string, and we can write select length, we add our string. If we execute that, we get the number of characters. For example, length, you can use it also in a where clause. For example, you want to select all the names where the number of characters equals to 5. Then we have lower function. So lower returns the string in lowercase. If you have your string in lowercase, so it will stay in lowercase. But if you have your string or your sentence in uppercase and you want to convert it to lowercase, so you write select lower and you add your string. So if we execute that, we'll get the string in lowercase. Okay? Then we have replace. So replace is used to replace a string in a sentence. Here the syntax is as follows. So you write select replace, you write here your sentence, here the string that you want to replace, and here you add your new string. Okay, so you write select replace your sentence or your list of characters, your string that you want to change, and here the new string. So if we execute that, we'll get data analysis. So we change science with analysis. Okay, so this is for the replace function. Then we have the reverse. So the reverse, it reverses the order of characters in a string. For example, here we have data science. If we select reverse data science, we'll get the following. So we get the reverse. Okay, so the last will be the first and the first will be the last. Okay, here right is, as we have said, we have left, it returns the leftmost number of characters, and for the right it returns the rightmost number of characters specified. Here if we have our string, we say right string and we put here the number of characters. So if we execute that, we get the 3 rightmost number of characters. Okay, same thing if we want to get only 2, we execute that and we get the 2 rightmost number of characters. Then we have the string comparison. By default, as it is defined within the MySQL documentation, it returns 0 if the strings are the same, -1 if the first argument is smaller than the second argument according to the current sort order. So if we have the first is less or has less number of characters than the second, it will return -1. If both of them are null, it will return for us null. Okay, otherwise it will return 1. So if we execute that, we'll get 0 because the strings are the same. If the first argument is smaller than the second, so if the first is smaller than the second, it will get for us -1. If the first is greater, it will return for us 1. And if both of them are null, it will return for us null. Okay, same thing here. If we have the same number of characters and the words or the string are not the same, it will get for us 1. Okay, so this is for the string comparison, strcmp. Okay, after that we have substring or substr. It returns the substring of a string starting from the defined position. For example, for the leftmost, if we write leftmost string 4, we select the 4 leftmost characters, but with the substring or substr, it is the same. Okay, you will select the substring starting from the 4th position. So if we execute that, we will get the following string. So 1, so D is 1, 2, 3, and it starts from 4, which is here. If we want to start from the space, write 5, and it will start from the space. So we have the space, then we have science. So substring returns the substring of a string starting from the defined position, which is in here. So write substring, your string, then you add your position where you want to start. Okay? Then we have trim, which removes leading and trailing spaces and the specified characters from both sides. So by default, it will remove spaces from the left and from the right, or it removes the specified characters from both sides. So here, if we want to remove the space in the beginning and at the end, we execute the following. Here we have the string with the spaces. Now we write select trim and we want to remove the space from the beginning and the space at the end. It will give us the string directly. Okay, and also if you have number of characters which are before a given string and after a given string and you want to remove them, you can write trim both, so z from the beginning and at the end as result, and it will get for us the same string. Okay, so you can remove leading and trailing spaces and the specified characters from both sides. Okay, so this is, for example, we have specified, we remove z from the beginning and at the end by writing both z from our string, and it will get it as a result, give us the following. Same thing if we write just trim and we have space at the beginning and space at the end of a word, so it will give us the word without spaces. For example, if we have only space at the beginning, okay, same thing, it will give us the same thing. Alright, so by default it will remove the space at the beginning and at the end of the word. Finally, we have the upper function, which returns the string in uppercase. So it is the opposite of the lower. So if we have a string in lowercase and you want to convert it to uppercase, we write select upper and we add our string, so it will be converted directly to uppercase. Okay, so these are the most used string built-in functions within MySQL. And for more details, I will put the link to the official MySQL documentation about the built-in function. So now we go to the second type, which is numeric functions. So the first function is the absolute value function, which is ABS. So we write select ABS minus 66, for example. If we execute that, we get 66. Same thing, the absolute value of positive number is a positive number. The second function is CL, which returns the next integer, which is greater than this decimal number. So if we write select CL 2.1 to select for us 3, even though if we have, for example, 2.001, okay, if we execute that, we get 3. Same thing for minus 2.1 to get for us minus 2. Okay, so minus 2 is the next integer after minus 2.1, and same thing for 3, it is the next integer after this decimal number. Okay, then we have the integer division. So if we want to perform integer division, we write select first number divided by the second number. If we execute that, we get 2. Okay, so 5 divided by 2 is 2.5, but the integer is 2. Same thing, if we write select 9 division 2, it will be same thing 4. Okay, so 9 divided by 2 is 4.5, and the integer is 4. Then we have the exponential. Okay, so if we write select exponential of 0, it is 1. Exponential of 1, it is 2.7, etc. After that, we have the floor. So floor is the opposite of CL. CL, it returns for us the next integer, whereas for the floor, it will return for us the integer before the decimal number. So here we expect 2. Same thing here, we expect minus 3. And same thing here, for example, if we have 2.999, the integer before this number is 2. Okay, so the floor is the opposite of CL. Then we have the modulus or mod. Okay, so if I write select 10 modulus 2, it will give us 0. Okay, so because 10 divided by 2 is 5, whereas for the select 9 modulus 2, it will give us 1. And same thing, we can replace mod with the percentage sign. It is the same thing, and both of them are used for the modulus. Alright, then we have power or pow. Okay, so these two numbers are the same thing, so we use that for power numbers. For example, if we want to calculate 2 to the power 10, we write select power 2 to the power of 10. Okay, same thing, if we write pow or power, it is the same thing. So here it is the number, and here it is the power. So 2 to the power of 10. Okay, then we have round. So round is used to round the numbers. If, for example, the decimal part exceeds 0.5, so 0.51, it will give us 3. Whereas if it is less than 50, so less than 5, the decimal part is less than 5, so it will give us 2. So round is used to round the number. Then we have square root. So SQRT is for the square root. So write select square root of 9. It will give for us 3. Finally, we have truncate. So truncate is used to truncate to specify number of decimal places. For example, here we have a number which has more than 4 numbers in the decimal part, and you want only to get 4 numbers in the decimal part. Okay, so write select truncate. We write here our decimal number, and here we write the total numbers that we want to have in the decimal part. So if we execute that, we'll get only 4 numbers. Alright, so this is about the numeric functions. Now we'll talk about the third part, which is date and time functions. We start by the first function, which is now. So now function returns the current date and time at which the statement begins to execute. Okay, so begins to execute, because we have another function which is state, which returns the time at which it executes. Okay, so if we select now, we get the current time. Okay, and this example is from MySQL documentation. So we write now sleep 2, which means that we stay or we wait 2 seconds, then we execute now, which is our function, the second time. So if we execute that, we get the same time. Okay, so we have here 12:56:19, 12:56:19. Okay, now returns the current date and time at which the statement begins to execute, whereas sysdate returns the time at which it executes. Okay, so we have here the same time, but if we execute sysdate sleep 2, so we wait 2 seconds, then we execute another time sysdate, we get the following. As you can see here, so we have 57, then we have 59. Okay, whereas for now we have exactly the same. Okay, we have the same time, right? So this is for now and sys date. We can also use current date to return the current date, okay? So we have the current date. Same thing for the current time. And now if we want to practice with some other functions, so I'm going to use the scikit database, okay? And when we select all from film, we can see that there is a column which has last update. So here we have the date and the time, right? Now if we want to select only the seconds in this column, so we write select second, so we write the name of the column from film, from our table. So if we execute that, we get the second for each row in the column which is called last update from table film. Same thing if we want to select only the minutes, so we write select minute last update from film. So we have the minute, then we have the hour to select the hour, to return the day name, okay, so we write select day name, the name of the column from our table. So get the name, it is Wednesday. The week, so it returns the week. Same thing for the month. And also if we want to select the month name, so write select month name, our column from our table. So it is February. Same thing, we have year, so select year, our column from our table. And we have the timestamp. So write select timestamp, the name of the column from our table. When we execute that, we get the date and the time. Okay. Finally, we have that diff, which is used to subtract two dates, and the result will be in days, right? For example, we want to calculate the difference between now and the date in the last update, column from film table. So here I used subquery, okay? Because if you want to execute that alone, so copy and paste that. So we'll have the column. And if we put all that in here, so we'll get an error which says we cannot do that because it returns more than one row. This is why we used limit, okay? So if we write limit 1 here, we get only one value. And for now, we have seen that it selects the date of today and the time. When we do the date difference, so it will calculate the difference between now and this date, okay? And the result will be in days, as you can see here. So we have our result in days. Or if you want to get it in, for example, months, we can divide by 30, for example. Same thing for years. Okay, so this is about the most used date and time functions. And here we have the official documentation for the built-in functions in MySQL and operators. Okay, here, for example, if you are looking for date and time functions, you can select date and time functions, numeric functions, string functions. Okay, so we'll have here the totality of the functions, of the built-in functions defined within MySQL for date and time, numeric, and string functions. Okay. In this tutorial, I'm going to talk about TCL commands. So TCL stands for Transaction Control Language. TCL commands are used to have more control on transactions, and a transaction can be defined as one or more logical SQL statements made by. So we have the data manipulation language commands, we have the insert, the update, and the delete. MySQL treats a transaction as a single unit, as we have said, with one or more logical statements, and the statements can be saved or not at the end of each transaction. We have three transaction commands. We have commit, rollback, and save point. Commit used to permanently save changes made with a transaction, whereas rollback is used to go back to a save point or to the previous state before the current transaction. without saving the changes. And save point is used to create save points, which allows to save one part of the transaction. A transaction starts with start transaction, and it ends when it is committed. So when using commit to permanently save changes, or rollback to roll back to a given save point or to the previous state. So to understand better, we are going to use the joins database, and we are going to use the first table. So in this table, we have 2 columns and we have 5 rows. So we have the ID and the name. The ID is an integer and the name is a character. As you know, by default, all changes are saved automatically in MySQL. For example, when you create a table, when you update, when you insert, when you delete, everything is saved automatically. So to remove that, we can set the auto commit equals to 0. For example, when we set auto commit equals to 0 and we update a table or a given row in a table, if we don't manually save the changes, nothing will be saved. Okay, so just to have more control on your queries and your SQL statements while analyzing. So as we have said, transaction starts with start transaction. We set first auto commit equals to 0. We start transaction. We insert into table 1 a new row. So we write insert into table 1. So I didn't write the name of the columns. So we add them in order. We write values 6, 6th row, and we add a character. So we execute that. And we have said each transaction ends whether it is committed, okay, it is saved, or when we use rollback. Here, when we use rollback, so we ignore this change. And if we select all from table 1, as you can see, nothing has changed because rollback is used to go back to the previous state before the transaction. So we come back to this state before inserting the table. Whereas if we start the transaction again, we insert and we use commit in the place of rollback. We execute that. So when we select all from table 1, as we have said, commit is used to save the changes in the transaction. So we started the transaction, we inserted a row, and we saved. So when select all from table 1, we can see the new row. Okay, so here we have one SQL statement in the transaction. We have used start transaction, and we have saved our changes. Okay, so now you can see the difference between commit and rollback. So I'm going to delete this row, right? Select all from table 1. Now we have the table. When we go to the second example, as we have said, it can be used with insert, update, or delete. So now we have an example using update. Same thing, we are going to use joins database. We select all from table 1. So we have the 5 rows. We set auto commit equals to 0. We start a transaction and we update. So update table 1, set name 1 equals to this character where ID equals to 5. Before we have said that we have ID where ID equal to 5, the name is null. Now we want to change null into this character. Okay, so we have started our transaction, we update our table, and we save that as save point 1. Okay, we call it point 1. So we save that. We do another update, so we will change the name where ID equals to 1. Okay, but we will not take this one into consideration because we will use rollback to point 1. So as we have said, save point, it will save for us a part of this transaction, which is the first, and it will not save this one. So when we write rollback to point 1 and select all from table, we can see that the ID equals to 5 has been taken into consideration, so the null value is replaced with this string, whereas where ID equals to 1, we didn't change the A with Z. Okay, we used the update, but when we used the rollback to point 1, MySQL ignored this update. Okay, so this is how we use rollback to save point. We create a save point, we give it a name, then when we roll back to this save point, we ignore these changes made after this save point. Okay, so this is used generally, for example, when you want to do some modifications on your table and you want to go back to the previous state. This is really useful. The other example is using delete. Okay, same thing, we are going to use joins. We select all from table 1. So now we have modified the fifth row. The null value is replaced with a character. We set auto commit equals to 0. We start a transaction. We delete, so we delete the fifth row. So write delete from table 1 where ID equals to 5. We save that, so now we have only 4 rows. We don't have the ID equals to 5 row. Save point. And after the save point, we will update. So write update table 1, set name 1 equals to z, where ID equals to 1. Same thing, since it is after the save point and we want to roll back to point A, so this will be ignored. Okay, so we will end our transaction by writing rollback to point A. And when we select all from table 1, we can see that the fifth row is deleted, and the first row where ID equals to 1, it has the same string. It did not change the A's into Z's. Alright, so as we have said, the TCL commands are used mainly with DML commands, which are insert, update, and delete. And these 3 comments are commit, rollback, and save point. And they are generally used to have more control on your SQL queries. In this tutorial, we are going to talk about window functions. So window functions are very powerful when working with SQL, since they allow us to perform and apply more advanced techniques that aggregation functions allow us to do in SQL. So to understand that better, we are going first to see how to use aggregation functions as window functions. To do that, we are going to use the word database, and we are going to use the country table. So in this country table, we have a lot of columns. Among these columns, we can find the name, the continent, and the population in each country. For example, if we want to get the sum of population in all the countries, which means that the global population, we can write select sum population from country. This query will return for us the sum of population in one single row and one single column. And by definition, aggregation functions aggregate or retrieve for us result where the number of rows is less than the total number of rows in the table. This is by definition. What if, for example, if we want to display the sum of population in all the rows? For example, if we want to display the name, the continent, the population of, for example, the continent, and it will be available in each row. Like here, for example, we have the name, we have the continent, and we want the population in the continent to be the 4th column, and it will be displayed in all the rows. When we apply aggregation functions, we are not going to get this result, since it allows us to get only a limited number of rows. As you can see here, if we want to select the sum of population in each continent, and if we want to add the name of country, we cannot, because the number of rows is limited to the number of continents. And we get the result using the aggregation functions and the group by. So group by will get for us groups of continents where the population of each continent is displayed. But when using window functions, we get exactly the total number of rows with a value assigned to each row. So we'll get exactly the number of countries, and in each row we'll get the, for example, the global population or the continent population, etc. And we get that using the over clause. So as we have said, we are going to select the name, the continent, and the sum of the population in the word. So we are not going to use group by, but we are going to use the over clause. Okay, so for example, if we omit this row, right, and we want to select only the global population, so we'll get the following. In each row, we'll get the global population. Contrary to the group by, the over clause will allow us to retrieve the global population in all the rows. So all this is seen as a window. Okay, so the window is seen as the total table in this example. If you want to create a window within the over clause, okay, so we use partition by. With partition by, we are going to select the population in each continent, and we are going to display that in another column. So if we execute that, as we can see here, we will get two new columns. We'll get the global population and the continent population. The global population will take in consideration all the table as window, since we have used over with nothing inside the parentheses, and we used an alias as global population. But in the continent population column, we have used partition by. So partition by will create partitions inside the over clause, and this partition will depend on the continent. As we can see here, the first partition is Asia, right? As we can see here, the first one is Asia. So this is our first window. In this first window, we are going to calculate the total population in Asia, and we are going to display it in this column. Same thing in Europe. So this is the second window or the second partition until North America. So it will calculate the population inside this window for each country, and it will display for us the result in all the rows that have countries in Europe. And same thing for the remaining. Whereas for the global population column, it will take all the sum of the population in the world, and it will give us the result in this column for all the rows. Okay, so this is the main difference between over and group by. So over, it will allow us to display the result in all the rows, whereas for the group by, it will aggregate, or it will give us a limited number of rows depending on the group by expression. And as you can see here, we can use over with nothing inside the parentheses, or we can use partition by. So partition by, it will create partitions inside the table. So here, by definition, the execution of queries follows this order. So first we work with from, then join, where, group by, having, select, distinct, order by, and finally limit. And as you can see here from MySQL official documentation, window functions are executed after the from, where, join, group by, and having, and before order by, limit, and select distinct. So this is for the order of the execution. And now we are going to talk about the non-aggregate window functions, which are the window functions used in MySQL. So same thing, we are going to use the word database, and our first function is the row number function. As you can understand here, it means that it assigns a number to each row. It is used to assign an integer to each row of the window, which is the partition, and this partition is defined using partition by within the over clause. It assigns peers different row numbers, which means that, for example, if we have two rows that have the same value, it will assign different row numbers. As we will see later on, there are functions like rank and rank, which assign the same row number to rows that have the same value. And the row numbers, they range from 1 to the number of partition rows. For example, here we want to select the name, the continent, the population, and we want to assign an integer or row number to each row. Okay, if we execute that, we can see that the column which is named row number assigns value from the first one up to the end, so up to the 239, because we have used over with nothing inside the parentheses. What is recommended when using row number is to assign integers to rows that are or that have a given order, because if rows are not sorted, giving numbers to each row will not have any meaning. So here, for example, we are going to select the same thing, but we are going to create partitions depending on each continent. So we are going to create windows that will depend on the continent, and each partition will be sorted by population in the descending order. So if we execute that, we'll get the following. So the first continent is Asia, and the highest population is as follows. It has row number 1. So we have until the 51. Okay, so all this is the first partition, starting from China up to Maldives, right? which has row number 51. So this is the first partition by continent. The first continent is Asia, and it is ordered by population by the descending order. So this is the first window. Same thing when we go to the second continent, which is Europe, it will start over. So we have 1 up to 46. Same thing here, we have a new partition, which is Europe, and it is ordered by population. Okay, the alias is as row number. So this is the name of the column. And we do the same thing for the other partitions. So here the partitions depend on the continent. And in each continent, we are going to order our population in the descending order, and we assign a row number to each row. Okay, so this is for the row number. And as you can deduce, over is used to define the set of rows that can be used as the window frame. As we have seen, we can use over with nothing inside the parentheses, which means that we are going to select all the rows or all the table. Or we can use partition by to classify the rows into groups. As we have seen, for example, each continent will have a set of rows, and for the set of rows we can assign, for example, a row number. Order by is used to order the rows within the window or partition. So as we have seen, for each continent it will start over, for example, from Asia from 1 to 51, then for Europe from 1 to 43, 46. So it will order the rows depending on the partition. And as you will see in the next function, there are what we call rows or range that are used within this frame or within a partition. And the frame can be defined as a subset of the partition or window. So rows is used to define a number of rows with respect to the current row, and range is used to define the values with respect to the value in the current row. And we'll understand that when we apply first value and last value functions. For first value, it is used to return the value of the first row in the window frame from the specified column. So as we have said, we want to select the name, the continent, and the population, and we want to select the first value in population column over. So here we define our window frame. We define our partitions by continent. So we have Asia, Europe, North America, etc. We are going to order that by population in the descending order. And here we use the range. As we have said, we use the range to define a range of values with respect to the value in the current row. So we start from the first value. If we execute that, we start from this value. So this is our first window. Okay. For Asia. And in our window, we are going to start from unbounded preceding, which means that we don't have any restriction for the values before the current row. And the next value, it will be current row. So it will be between unbounded preceding and current row. We start from the first row, we have this population. Preceding, we don't have any value before this value, and we have the current row. So the first value, it will be this value. If we go to India, so we have this one as the current row, and we don't have any restrictions for the values before this value. So we will have only these two values. And the first value, it will be this one. Same thing. So we go to the third, we go to the fourth, we go to the fifth, which means that we go row by row. And each time, the max population, we call it max population, is the first value. Since we have ordered our population in the descending order, this will be the highest value. Thus, it will be the value that will be displayed in max population in continent column. Same thing if we go to Europe, we are going to select our window for Europe, okay? Then we see our current row, unbounded preceding, so we don't have any value before this value. We go to the second, go to the third, we go to the fourth, and since we order that in the descending order, this will be the first value in our list, and we have called it max population in continent. Thus for Europe, it will be displayed for Russian Federation. And same thing, we are going to apply that to all our partitions. United States in North America, same thing. It will select the first value in this list, and since we have ordered that in the descending order, it will select for us this value. And if we don't specify the range, as we have here, write range between, and we write unbounded preceding and current row. This is the default value, even though if we do not specify the range, so this is will be the default value. Okay, as we will see in the next functions, we can modify and we can use other keywords rather than unbounded preceding and current row. So this is for the first value, to return the value of the first row in the window frame from the specified column. First, we specify our partitions within overclose. Then we give an order. For example, if we do that in the ascending order and we execute, so the first value in the list, it will be this one. Okay, so this is the value number 1. Thus it will be selected in here, and of course we can change the name, so since here it is the minimum population in the continent. All right, and as we have said, we can use the range for the values, or we can use the rows to select defined rows. Same thing, we are going to select this name, the continent, the population, and we are going to select the first value for column population over. So here we define our window. Same thing, partition by continent, order by population in descending order, rows between the current row and unbounded following. So this is the inverse of the previous example. If we execute that, we get the following. Since we start from the current row and unbounded following, which means that we are in the first row, so this is the current row, okay, and unbounded following, thus we have only one value in this list, and the first value, it will be this one. Same thing when we go to the second row. This will be considered as current row, and it will start counting from this row. Okay, so here the first value is same thing, it is the same, and so on. Next we have last value. So last value is used to return the value of the last row in the window frame from the specified column. Same thing, we are going to select the name, the continent, the population, last value from the population column, and here we define our window. So over, partition by continent, order by population. Okay, we can use that in the ascending on descending, so by default it is ascending. And rows, we don't give any restrictions for the preceding or the following rows. If we execute that, we are going to get the maximum value. Okay, here we have our first partition for Asia. Okay, and the last value in this list is for China. Okay, so we start from this one up to the end of, up to the last row in our partition, and it will select for us the last value. So in our case, it is the maximum population in this continent. Same thing, if we do that for Europe, we get the last value. So here in our list, the last value is for Russian Federation. Okay, as we have said, by default, order by population, it will be in ascending order, and the last value in this window frame is for Russia. Thus, in max population in continent column, we'll get only this last value. And we apply the same thing for the remaining partitions. Here we have another example where we are going to use one preceding and one following rows. Same thing, we are going to select the name, the continent, the population, last value from population, over, partition by continent, order by population. By default, it is ascending order, and we take in consideration one row before and one row after the current row. So if we execute that, as you can see here, so this is the current row. We'll take one before, so we don't have any rows before, and we take one after. So the last value in this list is this one. So we have two values in the list, and the last value is this one. Same thing when we go to this second row. So this is the current value. We take one before and one at the end. So we have this 3 as the list, and the last value in this list is this one. So it will put the last value in this one, where the column is called X. Same thing if we go to the fourth row. So we'll get one before, one after, and the last value is this one. Okay, you can put any number that you want. For example, you can put 3 preceding and 3 following. When we execute that, we get the following. So this value, it will take, we don't have nothing before, it will take the 3 after, and the last value is this one. So it will put the last value. If we go to the second, it will take 1 before because we don't have more than 1, and 3 after, and it will select for us the last value. So the last value in this list, it will be this one, because our window or our partition is dependent on the number of rows that we have defined in here. So this is the main things that we can use with rows and range. Define the range or the rows, and the total rows before or rows that are following the current row. Same thing in here, we have the other function, which is the nth value. With the nth value, it is used to return the value of the nth row in the window frame from a specified column. So here, same thing, we select the name, the continent, and the population. In the nth value, we specify the column, and here the row that we want to get its value. Okay, same thing, we define our window, so over partition by continent, order by population in descending order, and we call it, we put an alias 10th population in continent. So if we execute that, we get the following. For the 10 first rows, we don't have anything. Okay, as you can see here, for example, we can add the row number. Okay, so I'm going to select row number. Okay, and we add over partition by, we call it as y, for example. So if we execute that, we get the following. So until the 9th, we don't have anything. Starting from the 10th, we get this value. Okay, we have null because from 1 to 9, we don't have this value. It does not exist. Starting from the 10th row, so the 10th value in this partition, which is Asia, okay, is this one, okay, which corresponds to this country, which is Turkey, right? Same thing, we will get the same result for example, for Europe. Here for the 9 first rows, we don't get anything, so we get null values. Starting from the 10th, we will get this population of Netherlands, right? Same thing for North America, etc. So this is for selecting the nth value, which will depend on the exercise, okay? But the difference between the first value and the last value with the nth value is that for the first and the last, we put only the population, so we put only the column. Whereas for the nth value, we put the name of the column and we add the position, okay? And same thing, we can combine the 3 functions and we use them at the same time. We select the first value, we select the last value, and we select the nth value. So every column is separated with a comma, 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 and if we execute that, we get the following. So we'll have the name, the continent, and the population. We have the 3. Then we have the max population, the mean population, and the 10th population in continent. So this is when we want to use the 3 functions at the same time. Next we have lead function. So lead returns the value of the column from the row that leads the current row by n rows within its partition. For example, same thing, we are going to select the name, continent, and population. So we write lead, the name of the column, which is population, and we select only one row. We select our window, so over partition by continent, order by population in the ascending order, and we call it next higher population. So if we execute that, we can see that the row which is after this one is the next row, and we put this value in here. Okay, so this is the row that leads the current row. Same thing in here, the next row is this one, so which is next higher population, and we put it in the next higher population. Same thing in here, we get the next one, and so on. For example, if we put here 2, we execute that, and we get the second. So we have 1, which is the current row, so 1 after, 2 after. So this is the second row after the current population, and we put it in the next higher population. Same thing for this one, we have 1 and 2, and we put this value in here, and so on. So this is for the lead function, and it is used as following. So you write lead, the name of the column, and here the total number of rows. Same thing, we have the other function which is lag. Lag returns the value of the column from the row that lags. So here we have the row that leads, here the value, the row that lags. The current row by n rows within its partition. For example, if we execute that, we have the name, the continent, the population, same thing, we write lag. The name of the column is population, and we write only one column. Over, so we have our window, and here order by population in descending order. We can also add the condition. We select only the countries which are in Asia. If we execute that, we get the countries in Asia, and as you can see here, we don't have value before this value. Thus, for the first row in population of previous country column, we have null. Whereas here, the previous value is the population of China, thus it will put it in here. Same thing for Indonesia, and so on. Here we are going to use an example about year-over-year growth in a company, and year-over-year growth is used to measure the growth of a company from one year to another. Thus, by definition, it is calculated by subtracting the revenue of, for example, this year, 2022, with the revenue of 2021, and to see the difference. If the difference is positive, then this is a good sign. Otherwise, which means that the company is losing money. To do that, we are going to create a table. We call it a revenue table. It has a year and it has a value. So we execute that, and we insert into revenue table values. So here we add them in order: 2017, 2019, 2019, 2020, and 2021. And we have the revenue of each year. Okay, this is just an example. And if we execute that, select all from revenue table, and we have the following. So in 2017 we have this revenue, in 2018 we have this revenue, etc. Now to calculate the year-over-year growth, we are going to use the lag function. We are going to create a new column that we will call val previous year, which means that in here we will get another column for example, in 2018 we have here the value of 2018, and we'll get the value of 2017. We calculate the difference between these two, and we get our result. So if we execute that, we get the following. So for 2017, as you can see, we have only the value of 2017. We don't have the value of 2016, thus it will display for us null. Whereas for 2018, we have the value, and here we have the value of 2017. So we calculate this revenue of 2018 minus the revenue of 2017, we get the year-over-year growth. So it is negative, which means that it is a bad sign for the company. Same thing, in 2019 we have this revenue, and we have the revenue of the previous year. So the difference is positive, which means it is a good sign. So this is just an example where we can use the lag function, and as you can see here, we can use it to calculate the year-over-year growth. Next, we have until function, which is used to distribute the rows for each window partition into a specified number of ranked groups. For example, if we want to select the name, the continent, and the population, and we want to create 10 groups. Okay, so we want to create 10 groups in each partition. So our window is defined as follow: over partition by continent, order by population in a descending order, as group number. From country, and we are going to select only countries that are in Asia. If we execute that, we get the following. As you can see here, I have written here select count name from country where continent is Asia, which means that it will give us all the countries that are in Asia. So we have 51. If we want to create 10 groups in 51 elements, we have to create 9 groups which have 5 elements and another group which has 6 elements. So when using until 10, we are going to get the first group. We will have this 6 elements, okay, by default. Then the second group will have 5 elements. The third group will have 5 elements. The fourth group 5 elements, etc. until the 10th group. As you can see here, we have created 10 groups in the partition where continent is Asia, And in this partition, we have 51 elements. The first group, it has 6 elements, and the remaining, they have 5 elements. For example, if we omit the condition where continent is Asia, we can see the following. So for the first continent, first window, up to the 51, it is here, okay? Then when we go to the second partition, which is Europe, it will start counting over. Same thing, we are going to select the first group, the second group, the third group, etc. until the 10th group. So as we have said, entile is used to distribute the rows for each window partition into a specified number of rank groups, which we define inside the function. Now we'll talk about ranking functions. So we have mainly 3 different functions. We have rank, percent rank, and dense rank. So for the rank, it must be used with order by, and it returns the rank of the current row within its partition with gaps. And peers are considered ties and receive the same rank. As we have said earlier, for row number, peers receive different numbers. Whereas with rank, if there are peers, they will receive the same number and the same rank, but with gaps. As you will see here in this example, so we are going to select the name, the continent, and life expectancy. Right, rank. Then we select our window. So over, partition by continent, order by life expectancy in the descending order. And we put an alias as my first ranking. So if we execute that, we get the following. So the first window is for Asia, right? And we have here life expectancy from the highest to the lowest. And as you can see here, so we have the ranking. But when we get, for example, to the ranking number 15, we have the same values. And as you can see here, we have 15 and 15. But for the next value, we don't have 16, we have 17. This is why it is called ranking with gaps. Whereas, for example, if we use the dense rank, which is also used with order by, you can see here that for the same value, which is in here, we have 15, then 15, and for the next value, it will be 16. So here we have ranking without gaps. Okay, so this is the main difference between rank and dense rank. Both of them, they must be used with order by. And for the percent rank, so it returns the percentage of partition values less than the value in the current row. Of course, excluding the highest value. So the range is between 0 and 1 and represents the row relative rank. So if we execute that, we get the following. So we have 0, 2%, 4%, 6%, etc. Same thing when we get to the same value. So we have from 0.26, 28, then 32. We don't have 30, so we go directly to 32. Okay, same thing in here. 0.32, we go directly to 0.36 since we have 2 values that have life expectancy, which is 71.4. Okay, so for example, if we want to display all these ranking functions with row number in the same table to compare ranking with the other, we can use the following. So again, copy and paste all this. Okay, and we are going to add the row number. So we're going to put that as row number. Here we are going to change it to row number. Okay, so if we execute that, we get the following. So as you can see here, for the ranking, it is for row number. When we have the same value, it will assign different numbers. Okay, so we have 15 and 16 even though we have the same life expectancy. For my ranking one, which is the rank function, it will select for us 15, 15, then we have a gap, so we don't have 16, we go directly to 17, and same thing, we jump directly to 19. For the dense rank, we have 15, 15, 15, then we have 16, 16, and then we have 17, which means that we don't have gaps. Whereas for the percent rank, it will select for us the percentage. Okay, so this is for the ranking functions. And finally, we have the CumDist function, which calculates the cumulative distribution of a value in a set of values. Same thing, we are going to select continent, name, and life expectancy, and we are going to select our cumulative distribution, and we are going to round that into 2 decimal numbers. Okay, same thing, we select our window using over, partition by continent, order by life expectancy, and we call that as life expectancy cumulative distribution. So if we execute that, we get the following. So the count is the total of countries within each continent. As you can see here, we have count of name in each continent. For example, in Asia we have 51, and as you can see here, so when we have 1 divided by 51, it is 2%. Then we add 2% to 4%, then we add 4% to 2%, etc. So this is what we call cumulative distribution, and we use camdist to calculate that using MySQL. So I've arrived to the end of this video. I hope that you have learned new things and you have understood how to work with MySQL. Thank you for watching and see you in the next video.